And we're going to go ahead and switch over to our PowerPoint. Okay. So tonight we're talking about things like threat intelligence sources. So organizations are now pulling resources and knowledge about latest attacks with the broader security community. One type of shared information is the evidence of an attack. Key risk indicators, or KRIs, are metrics of upper and lower bounds of specific indicators of normal network activity. These indicators may include the total network logs per second, number of failed remote logins, network bandwidth, and outbound email traffic. Sometimes they'll call that your baseline. They'll say, run your network for a while to establish what is considered a normal baseline. And the reason that they do that is so that you can tell, okay, this is definitely outside of what's normal. If KRI exceeds its normal bounds, could be an indicator of compromise. An IOC shows that a malicious activity is occurring, but is still in the early stages of an attack. IOC information aids others in their predictive analysis or discovering an attack before it occurs. When a lot of threat intelligence scanning first started, it was kind of compartmentalized between different agencies, between different companies. But then when threat actors started attacking mass scale, and then we had script kiddies and things like that, it was very clear that keeping this information to yourself became more harmful to the community as a whole than keeping it a secret. So they started creating like databases, and that's where you get those security conferences and the hacker conferences and things like that, so that you can share your information and hopefully prevent things from happening. Categories of sources. So there are two categories of threat intelligence sources that are open sourced and closed source. So open source information is the same kind of premise as software. Open source refers to anything that could be freely used without restrictions. Open source threat intelligence information is often called open source intelligence. So if you ever see OSINT or OSINT, sometimes they'll pronounce it like that. That's what they're talking about. Cyber Information Sharing and Collaboration Program, or CISCP, enables actionable, relevant, and timely, unclassified, there's the big one right there, information exchange through partnerships. CISP services include analyst-to-analyst technical exchanges, CISP analytical products, cross-industry orchestrations, and digital malware analysis. That's where you get a lot of sometimes you'll have subscriptionware and things like that that you can be part of, and professional organizations and things where you can have that too. Yeah, JSOC, that's another, it's where you can use a lot of that. Mike, do you want to explain what you're talking about by JSOC?
Yeah, JSOC is Joint Special Operations Command. Basically a joint unit within the military that mostly does like a lot of special ops kind of stuff, but they get guys like me who are analysts. And we kind of just like look at everything intel based from, as you said, open source intelligence to actual satellites in the air, looking data pictures and stuff. But yeah, we use OSINT. We had some like OSINT kind of tool to actually monitor Twitter, and you'd be amazed what like these terrorist organizations would post and brag about, not realizing that their information is out there for everyone.
Yeah, OSINT is an amazing thing to use if you're in something like, especially with military and JSOC type stuff. It's really, really powerful information. Yeah, I actually have a funny story about that. So I know most of you know I work for the state police. One of the funniest things I ever heard from an evidence person was when he came in and said he had a whole bunch of stuff with him, and he said, I can't believe where we got all this. I was like, okay. And he said, we busted a bunch of people because they had a group on Facebook, and there was like no security settings on this group either. and all they were doing was sharing pictures of themselves with paraphernalia, like drug paraphernalia, selling drugs, drug paraphernalia. Like, I love social media. It's the best thing that's ever happened for law enforcement. And I was like, oh, it was just truly a spectacular example of dumb criminals. I'm like, yeah. Oh my gosh, yeah, there you go. That's fantastic. Yeah. So a lot of times people will brag about stupid stuff. They'll be like, hey, guess what I got to do? And the purely fantastic ones are the ones that actually take screenshots of them doing things like hacking into databases, or yeah, street racing, where they'll be on the cameras and be like, look, that's me. And you know, it's just it's you think, oh, nobody can be that dumb, and then you're like, wow, that just took it to a whole extra level of dumb. So yeah, social media, it's that whole people can be smart as individuals but really dumb as a group. Social media really feeds off of that. So two concerns about public information sharing centers: privacy, obviously. An organization that is the victim of an attack must be careful not to share proprietary or sensitive information when providing an IOC and attack details. So you have to be very careful to sanitize the information that you're sending out, and make sure that whoever is sending it out knows what is appropriate, what is not appropriate to send out. Speed, automated indicator sharing enables the exchange of cyber threat indicators between parties through computer-to-computer communications. Two tools facilitate AIS: structured threat information expression, STIX. I'm just going to say that instead of the rest of it. That's a language and format used to exchange cyber threat intelligence. And then trusted automated exchange of intelligence information, or TAXI. I swear they just cram these in so that they sound like the words. Is an application protocol for exchanging cyber threat intelligence over HTTPS. So STIX and TAXI. And then we have closed source information. This has to deal with proprietary information. Organizations that are participants in closed source information are part of private information sharing centers that restrict both access to the data and participation. And all candidates have to go through a vetting process and meet certain criteria. So you're dealing with either intellectual property, you're dealing with things like government clearances. There, you have to have some sort of hoop that you have to jump through in order to prove, yes, I should have access to this information. And usually, yeah, they're regulated. Usually, depending on the type of information, they're kind of, I kind of like to think of it like concentric circles. Like, there are different types of them. There's some that are proprietary that are they're kind of proprietary, and then you get the ones that are all the way down to the inside that are like, this is the NSA level. You have to have top security clearance type stuff in order to get into it. They do have those as well, but you really, really have to have a lot of clearance, and sometimes you can't even get to those unless you're on a physical air-gapped server in order to see the information, depending on what's there. Okay. Sources of threat intelligence that are useful. So there are vulnerability databases. Those are a repository of known vulnerabilities and information as to how they've been exploited. Threat maps, they are very fascinating. Threat maps illustrate cyber threats overlaid on a diagrammatic representation of geographical area. File and code repositories are where victims of an attack can upload malicious files and software code that can be examined by others to learn more about the attacks and craft their defenses. You see that a lot when you have security suites. A lot of times they'll be like, hey, we didn't see this particular brand of attack before. Would you like to submit it to our center for us to look at this? And if you say yes, it goes in into their repository and they can add it to that. And then there's the dark web. Security professionals and organizations use the dark web on a limited basis to look for signs that information critical to that enterprise is being sought out or sold on the dark web. You have to know what you're doing, and even sometimes if you know what you're doing, you can get the wrong stuff. Okay, so this is what a live cyber threat map looks like. Well, obviously it's not live, it's a screen capture of it. But you can see, depending on what security product you're using, it'll have all these cool little things, and it'll tell you, it'll map out where they're coming from, how many attacks, your top targeted countries, which industries they're coming from. It's really, really fascinating. I actually love this feature. If you ever get to work with a full suite that has that in there, and you can just let it run, it's so much fun to just watch it bing around and see exactly where the different things are coming from. Yeah, because that has some interesting stuff on it too, but you have to be careful with that one, because if you work for any government agency, Kaspersky is actually on a one that you're not supposed to use for certain government entities, because they're owned by a Russian, yeah, they're on a no-no list because they're owned by a Russian company. Yeah. Okay, and this is your example of the dark web. I just think it's funny because everyone makes such a big deal about it, but really it's just different levels of how you can access that particular thing. So there's your regular web up there, your deep web, and then your dark web is where you go down for your like onion router websites that you have to go into. All right, knowledge check. What is the significance of a KRI exceeding its normal bounds? It must be referenced to the DHS. It could be an IOC. It probably contains a TTP. Gotta love all these. And AIS should be generated. Go ahead and guess, because I know there's a lot of new acronyms there. Couple more guesses. Pick a letter and go for it. Like that. Here, make a couple extra guesses for people. There you go. Okay. Okay, so IOC is indicator of compromise. So what they were talking about is it could be an indicator of a compromise. Okay, securing endpoint computers. So when they're talking about endpoint computers, they're talking about end user computers. So securing endpoint computers primarily involves three major tasks: confirming that the computer has started securely, protecting the computer from attacks, and then hardening it for even greater protection. And how you harden the computer depends on what type of environment that you're in. Confirm boot integrity. Ensuring secure startup involves the Unified Extensible Firmware Interface, UFI, and its boot security features. I'm not going to read that every time. So UFI, early booting process, use firmware called BIOS, which if any of you have been working on computers as long as I am, have the BIOS is what came first, and it was all text, and then UFI came second to give you more of a GUI-based interface. Add functionality, improve firmware interface was developed to replace BIOS. UFI includes ability to access hard drives that are larger than 2 terabytes, support for unlimited number of primary hard drive partitions, fast booting, support for networking functionality in the UFI firmware itself to aid in troubleshooting. Okay, so this is just an example of what a UFI boot looks like. And if you've worked through the BIOS, it's just text. Yeah, and somebody knows their stuff. They immediately gauged which one that was off of. Okay, boot security. The ability to update the BIOS in firmware opened the door for threat actors to create malware to infect the BIOS, called BIOS attack. Boot security involves validating that each element used in each step of the boot process has not been modified. The process begins with validation of the boot software, Then it can validate the software drivers and so on until control has been handed over to the operating system. This is called the chain of trust because each element relies on the confirmation of previous element to know that the entire process is secure. Strongest starting point is hardware, which cannot be modified like software, known as hardware root of trust, which is funny because I've never actually heard it called that, but okay, we'll call it that. Protection of endpoints. Protection on computer endpoints can be accomplished through software installed on the endpoint, such as antivirus, anti-malware, web browser protections, and monitoring and response systems. Antivirus, at the very least, they should have antivirus. Antivirus software can examine a computer file-based virus infections and monitor computer activity, such as scanning new documents that might contain a virus. Log files created by AV products can provide beneficial info regarding attacks. Many AV products use signature-based monitoring called static analysis. If you remember me talking about AI and machine learning yesterday, that's what I was talking about. They use those now to help, instead of the static analysis, they use those. Newer approach to AV is heuristic monitoring called dynamic analysis. Anti-malware is a suite of software intended to provide protections against multiple types of malware. Anti-malware spam protection is often performed using a technique called Bayesian filtering. This filters by analyzing every word in each email and determines how frequently a word occurs in a spam pile versus a non-spam pile. Some of these products are better than others at these, and some just kind of suck. Another component of an anti-malware suite is anti-spyware. I can guarantee that as an IT professional, at some point in time, you're going to run into spyware, which helps prevent computers from becoming infected by spyware. Uses pop-up blockers, which allow the user to select level of blocking, ranging from blocking all pop-ups to allowing specific pop-ups only. And there are some websites and some products that require pop-ups, so you have to use them. Web browsers. Web browsers offer the following security on endpoint computers. Secure cookies are sent to a web server with an encrypted request over the secure HTTPS protocol. This prevents an unauthorized person from intercepting a cookie that is being transmitted between the browser and the web server. HTTP response header are headers that tell the browser how to behave while communicating with the website. Monitoring and response systems. Okay, so this is your HIDs, NIDs, HIPs, those. There are 3 types of monitoring and response systems for endpoint computers. Post-intrusion detection systems, or HIDs. This is a software-based application that runs on the endpoint computer and can detect an attack that has occurred. Post-intrusion prevention systems, remember that distinction, monitor endpoint activity to immediately block a malicious attack by following specific rules. So the one detects, the one prevents. Endpoint detection and response, EDR tools, are considered more robust than HIDs and HIPs. And EDR can aggregate data from multiple endpoint computers to a centralized database. EDR tools can perform more sophisticated analytics and identify patterns and detect anomalies. A lot of companies are going to EDRs. In fact, at the school district, we used, because they have, basically, they combine the HIDS and HIPS. And if you have a really good EDR, it takes a lot of your work as a security professional out and will just alert you as to what it's done. And it will alert you and be like, hey, I did this thing, is that okay? And then you set rules up, and they're actually very, very useful. Okay, hardening endpoints. So remember me talking about different places that you work, different things. The 2 most important ones, regardless of where you work, are patch management and operating system protections. Regardless of where you work, those 2 will be there. So patch management, effective patch management involves 2 types of patch management tools to administer patches. There's patch distribution using automated patch update services. Patch reception in Microsoft Windows 10 includes the following: forced updates, no selective updates, and more efficient distribution. I have some comments on patch management that I'll tell you after this. Operating systems. Securing an OS involves proper security configurations and using confinement tools. A typical OS security configuration should include the following: disabling unnecessary ports and services, disabling default accounts passwords, employing least functionality. That's usually done by group policies. In Microsoft Windows, security template is a collection of security configuration settings that can be used to deploy security settings to multiple computers. Windows 10 tamper protection security feature prevents Windows security settings from being changed or disabled by a threat actor who modifies the registry. A group policy setting can also prevent access to registry editing tools. And it looks like, there you go, that's the local group policy editor. Now, the point of group policy editors is you push them out from your main source, and when they right as they log in, they inherit them. So you have, instead of having to do by computer, you can manage all of them this way. It's much better as a system administrator than it is. Yeah, it's much faster. Confinement tools. Several tools can be used to restrict malware. Application whitelisting, blacklisting, that's become more and more important to know about. I'm seeing that pop up. You wouldn't think in school districts that you would see that, but I'm seeing that pop up more and more in there. Definitely in medical industries. And you have sandboxes, and then you have quarantine. I don't know if you know what application whitelisting and blacklisting is, but if they're very, very strict, there are some places where if you do not get, they'll have just like everything's blacklisted. You can't run anything that isn't on the application whitelist, and you have to go through a big process to even get your stuff approved, depending on, obviously the school district didn't do that because that's way too much manpower, but like most medical places and things like that will have severe things like that. So this is just an little application interacting with an operating system explanation. And this is how it works with a sandbox. Okay, so patching. One thing that a lot of places do is they'll use an automated patching system. Have you guys heard of that? Yes, no. Yes and no. Okay, so there are different products. You can create your own, and there are really great ones. Ivanti is, or it's either Ivanti or Ivanti. I can't remember how it's pronounced. It starts with an I, so it just depends on how you pronounce it. It makes an excellent one, and it basically it automates all of the patching all the way across from server to endpoint. It's really, really cool. So it's patching automatic updates. It's pretty cool. So if you ever get a chance to use one of those, go for it because it makes things a lot faster. Because 9 times out of 10, if the end user is given the option to run a patch, they won't. So just be aware of that. Knowledge check. Which of the following is not a tool that can be used to confine or restrict malware? Whitelisting, quarantine, sandbox, legacy boot. I was going to say, they made this one pretty easy. Yep. And okay. Creating and deploying Sec DevOps. An unsecure application can open the door for attackers to exploit the application, the data it uses, and even the underlying operating system. Do you remember that penetration testing when he was using Metasploit and all that stuff? That's an excellent example of that. Directory traversal attack takes advantage of vulnerability in web application, program, or web server software so that a user can move from the root directory of to other restricted directories. The ability to move could allow an unauthorized user to view confidential files or enter commands to execute on a server known as command injection. Other dangerous weaknesses in an application can create vulnerabilities in computer memory or buffer areas that can be easily exploited. Poor memory management vulnerabilities result in attacks such as buffer overflow, integer overflow, pointer object deference, and DLL injection attacks. All right, so this is just an example of what a directory traversal attack looks like. So if you look, they start in one and then they just slowly go boop, 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 and work down to wherever it is they want to go. Yep. And like Blake, if you remember what he was doing in Cali, when he was like, oh, I can't get there. Oh, okay, well, why don't we try this and this and this? And boom, look, now I can get there. And that's exactly what happens. Application development concepts. Two levels of application development concepts include general concepts that apply to all application development and those that apply to a rigorous security-based approach. General concepts. Developing an application requires completing the following stages. So you have your development, testing, staging, and production. Software diversity is a software development technique in which two or more functionally identical variants of a program are developed from the same specification, but by different programmers or programming teams. The intent is to provide error detection, increased reliability, and additional documentation. Basically, they want to see, okay, if we do this slightly differently, are we going to have the same outcome, or are we going to, it's just like with a scientific hypothesis. They want to see how many times they can make it do the same thing, if they can make it run reliably, or if they run it in a slightly different scenario, if it just crashes and dies. Provisioning is the enterprise-wide configuration, deployment, and management of multiple types of IT system resources. Deprovisioning in application development is removing a resource that is no longer needed, and honestly, it is not done well enough in most places. You have to remember that as part of your life cycle. Deprovisioning is important because if you don't, you have a lot of extraneous stuff out there that's not getting patched, it's not getting used, that is nice, big security hole. Integrity measurement is an attestation mechanism designed to be able to convince a remote party that an application is running only a set of known and approved executables. SecDevOps, an application development lifecycle model, is a conceptual model that describes the stages involved in creating an application and are usually one of the following two. There's the waterfall model. This uses a sequential design process, and then the agile model, and this one takes an incremental approach. So this SecDevOps is the process of integrating secure development best practices and methodologies into application software development and deployment processes using the agile model. SecDevOps applies automated courses of action to develop code as quickly and securely as possible. And that's the big section there, because a lot of times when software was originally being developed, security was not even remotely in the first round of design. So they found that later on, when you were trying to cram secure design in or fix it so it was secure, it was nearly impossible. So they had to go back and rewrite it so that you could have secure development from the beginning. So the automation enables continuous monitoring, continuous validation, continuous integration, continuous delivery, and continuous deployment. Secure coding techniques. Several coding techniques should be used to create secure applications and limit data exposure or disclosing sensitive data to attackers. These techniques include determining how encryption will be implemented, ensuring that memory management is handled correctly so as not to introduce memory vulnerabilities. Remember me saying that if you have a web server that is allowing buffer overflow, it means that you've got badly designed software. This is where that goes in. Code testing. Testing is one of the most important steps of SecDevOps. Testing should be performed during the implementation and verification phases of a software development process. Testing involves static code analysis and dynamic code analysis. So static code analysis, these are tests run before the source code is even compiled and may be accompanied by a manual peer review. If you're smart, it's accompanied by a manual peer review. I'm a huge proponent of peer review at as many stages as you can get, because the human eye, if we've been looking at something over and over and over again, you can miss all sorts of things because you just skip over it because you think this is what I should be seeing, and you right over the top of it and don't realize, oh, I just skipped over a major problem like 9 times because I was thinking about what I should be seeing, not what I'm actually seeing, which is why peer review is so important. Then there's dynamic code analysis. This is security testing performed after the source code is compiled, and that's why it's called dynamic code analysis. Fuzzing is used by dynamic code analysis tool and provides random input into a program in an attempt to trigger exceptions. So basically it uses, it's not really data that you would use in a live, it tries to use data that will break things. It's kind of like our hack it to fix it thing, only in a coding environment. So this is an example of automated static code analysis tool. And as you can see, if you're doing this, you should have like your line numbers on, so you have an easy way to get an easy way to visibly see your lines. And then there are different input generators like this one. And there are all sorts of them that you can come up with. And basically they just create the fuzz input generating stuff so that you can see what you can break. Okay, knowledge check. Which of the following best describes static code analysis? Testing uses a suite of pre-built attacks. Tests are run before the source code is compiled. Random input is used to trigger exceptions, used after all components are integrated. Good job. Looks like everyone saw that on there. Okay, self-assessment. What's this? Wait a minute. No, that's one of those. If you want to do it, you can. Okay, so that's the end of this one. It was kind of a short one, but I figure we've had a lot of information crammed into our brains this week. So are there any questions? Any questions about labs or anything you guys want to go over? Any questions about assignments? Yes, no. I want to go, yes, starting at 5, we're going to go over labs. I would highly recommend that you come and do that with me, even though there are some very simple labs that we're going to be going through. But if you want to go through those with me, I will be there and we will walk through them all step by step. And yeah, so yeah, we'll do those. And every week we'll be doing those from 5 to 7 on Fridays. And like I said, I highly recommend that we do that just so you can get your labs done. And if you have any questions with them, that's a good way to get them answered. Okay. If that's all, you guys go have a great night and go get your reading done and work on your papers and everything else. Okay. Have a good night.